Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's the only way you can help me promote my channel to your friends and to keep me going, refreshed and inspired of this very tiring work. Also, if my videos are important to your studies, then don't forget to subscribe. By the method of least work, find the horizontal component of the right reaction of the arc thrust shown below due to bars BC and CD 6.35 mm too short and bar CF is 3.175 mm too long. Owing to errors in fabrication and it was necessary to force them into place. Cross-sectional areas in square millimeters are shown in parentheses. Modulus of elasticity 207 gigapascals and coefficient of thermal expansion 12 times 10 to the negative 6 per degree Celsius. So here is the figure. Again, this is the continuation of the problem. I just make them a separate problem, this time by fabrication error. This is indeterminate to the first degree with respect to the external reaction. So we select the horizontal component of the reaction at E to be the redundant. So this should be to the left at E, and we base it from E here, our results. So as before, I leave the statics to you, and we already have experience from the preceding examples. Then we have colored coding for members with the same cross-sectional areas. So we put the values here, and if you have studied the previous problems, then this will not be new to us. So 1.118 EX, negative 0.5 EX for AB, negative 0.559 EX for BC, for BF, positive 0.559. Since they are equal, then we can solve CF, positive 0.5 EX. Take note that CF is the only member here, so its value should be equal to this, then plus for S, partial of S with respect to EX times length over AE, then one value here, one value there should be divided by 2. So tabulating, that is AB, negative 0.5 EX, partial derivative, negative 0.5. The length is 3, and the product, then the product of partial of S with respect to EX and the fabrication error. For too long, it is treated positive, but for too short, it is treated negative. So since AB is not involved for fabrication error, so it's 0 here. For AF, it's 1.118x, partial derivative 1.118. The length is 3.354 meters, then the product 4.192 EX, then AF is not involved in fabrication error, so 0. BC, negative 0.559 EX, negative 0.559, the length 3.354, then the product 1.048 EX. BC is involved in fabrication error, so this is treated in meter. So let's just treat that in meter. So negative 0.559 times negative 0.00635, so positive 3.54965 times 10 to the negative 3. BF is not involved in fabrication error, 0.559 EX. So we only analyze the left half by symmetry. And we note that CF is the only one member which has no identical member, so one value of S, partial of S with respect to EX times length should be multiplied by half. in our calculation. So 0.559, length 3.354. Then this is 1.048 EX. BF is not involved in fabrication error, so that's 0. Finally, CF is involved in fabrication error. Its force is 0.5 EX. Partial derivative 0.5. Its length 3. Then S, partial of S with respect to EX times length is 0.75 EX. Its fabrication error should be divided by 2 because it is the only one member, so we should divide it by 2, the product here, this product. So 0.5 times positive 0.003175, then divided by 2. So that's 1.5875 times 10 to the negative 3 divided by 2. So the sum is equal to 4.3434 times 10 to the negative 3 after we divide this by 2. So sum, which is 4.3434 times 10 to the negative 4, is equal to summation of S, partial of S with respect to EX, length over AE, and that is equal to, for this color value, 0.75 EX plus 0.5 of 0.75 EX. I already explained why do we multiply this by 0.75 over area 93.5 rather, over area times E 207 gigapascals times 1000 to make the unit consistent with meter here. Then plus the pink 4.192 EX 1000 over area 7200 times 207,000. Then for these two combined, 2.096 EX times 1000 over 10,500 over 207,000. So combining, we have 9.184 times 10 to the negative 4 EX times 1000 over 207,000 equals 4.3434 times 10 to the negative 3. Solving for EX, it is positive, so it agrees with this direction. Therefore, EX is 978.82 kilonewtons to the left, or to left. So that's it for this problem.